So let's look at this example. An airline executive is interested in knowing the average travel time of its flights from Los Angeles to Chicago O'Hare. She takes a random sample of 50 flights. The sample mean, X bar, is 180 minutes. The population standard deviation, sigma, equals 20 minutes. Find the 95% confidence interval. Okay, so let's have a look at what information we're actually given here. We're told that we have, don't have the population data, this would be the population. We do have a sample though, we're told we have a sample of n equals 50, 50. And we know that the sample mean, the average flight time, is 180 minutes. So 180. And we're told that the population standard deviation, not the sample one, but the population one, is equal to 20 minutes. Okay, and they want us to find a 95% confidence interval, which means alpha, our significance level, is 5%. So for this question, we have to figure out, is it a Z, is it a T, what sort of question is it? And we know that because we're given the population standard deviation, because this guy is known, then this will be a Z distribution question. So all we need to do to get the interval estimate is work out this formula. So start off with a generic form. It's going to be the point estimate minus the margin of error. For the lower limit, the upper limit is going to be the point estimate plus the margin of error. And we have the point estimate is going to be X bar. So the point estimate is just this value in here, right there, 180 minutes. Remember, the margin of error is going to be the critical value times the standard error. And for the upper limit, it's going to be the same thing, except with a plus sign. It's going to be X bar plus critical value times standard error. Okay, and so for us, let's see, because the population standard deviation is no, we know the critical value is going to be minus Z of alpha over 2. Z of alpha over 2 times the standard error, going to be sigma over the square root of the sample size. And similarly on this side, it's going to be the same thing except with the plus sign, plus Z of alpha over 2 times the standard deviation over the square root of the sample size. So X bar, this is X bar is 180, sigma is 20, the sample size is, that's a 50, isn't it? Doesn't look like a 50, but it's a 50. And so the only thing we need to work out is this Z of alpha over 2. We know the rest of the information. So why don't we do that? So Z of alpha over 2 is going to be equal, well, alpha is 5% up here. So Z of alpha over 2 is Z of 2.5%. So Z of 2.5%, do a little graph or a little diagram of it. We have a normal distribution, and Z of 2.5% is this point here, where this area in here, which I'm just shading in, is 2.5%. So to actually calculate this, we can just use norm.s.inverse. So norm, in Excel that is, norm.s.inverse, norm.s.inverse. And that's going to be the area to the left of this point from this point onwards. Well, if it's 2.5% to the right, it has to be 0.975 to the left. And there you go. And we can work that out. Now we actually worked that out earlier, but let's just work it out again. Let's go over to Excel. So we can do equals norm dot s dot inverse of 0.975, and let's see what that gives us. Oh, about 1.96. Okay, so all we need to do now is just come over to here and put the 1.96 in and the rest of the values in there. So we can actually come down to here. So x bar, we already know that x bar is 180. And with subtract, we just worked out that this guy in here comes to 1.96, approximately 1.96 times the standard deviation, which we said is going to be 20 over the square root of 50. And that gives us the lower confidence limit. If we want the upper confidence limit, it's going to be the same thing as this, except we're going to put a plus sign in here. So it's going to be 180 plus 1.96 times 20 over root 50. So it's up to you how you do this. You can try and crunch it on a calculator. I would personally not recommend that. I'm just going to pop back over to Excel, and let's see what we can do in Excel. So in Excel, we already know that that is going to be our critical value. So the calculation is going to be equal. Well, let's put the we can actually crunch out the calculation, or we can actually try and solve it in different ways. So we can say this is our critical value, and then we can move down to here. It's our critical value, and we already worked out what x bar was. Let's just write x bar, and x bar is 180. And what else do we need? We've got x bar plus or minus z of alpha over 2 times the standard deviation. So I'll just put standard deviation in there, and standard deviation, and that's going to be 20. I think that's a remnant of something we had before. Let's change that from percentage. It shouldn't happen on your one. It's 20 standard deviation, and the last thing is the sample size, and the sample size is going to be 50. So if you remember the way we work it out, the lower limit is going to be equal to x bar. So let's do equals x bar minus, for the low limit, z of alpha over 2, or the critical value, which is that guy, and we're going to multiply that guy by standard deviation, and then we're going to divide that out by the square root SQRT of the sample size, and the sample size is 50. Close the parentheses, and that should give us the lower limit. And likewise for the upper limit, what we can do is the same thing with a plus sign in it. So it's going to be x bar, but this time it's plus rather than minus the critical value times standard deviation divided by the square root of the sample size, and we're going to get our two limits: 174.4546, 185.5554 are the upper and lower limits. When you actually calculate this, if you actually calculated it using the exact figures like I did, you're going to get the same values. But if you rounded, say for example, the critical value to 1.96, and if you did the square root, instead of doing it inside, you did it elsewhere, and you copy the value in, you're going to get slightly different values. But let's put this to 2 decimal places. Let's go up here, and let's reduce the decimal places down to 2. So it's 174.46 up to 185.54. So we can go back to here, just complete this, the solution of, so your lower limit we said here is going to be 174.46. You can write the final answer in parentheses with a comma, and the upper limit is going to be 185.54 to 2 decimal places. So that's interesting. So we think that the flight time based on a 95% confidence interval from LA to Chicago O'Hare is somewhere between 174.46 minutes and 185.54. We think that the true average is somewhere in that range. There's a 95% probability, approximately 95% probability that we're actually correct, that it really does lie in there. But there's a 5% chance, because this is 95% confidence, so there's a 5% chance that the actual true amount of time, the true average flight time from LA to Chicago O'Hare is not in that range. But it's more likely than not that it is in that range because it's a 95% confidence interval. The only other thing I will do is show you that this part, we could have actually calculated, if you needed to, you could have actually calculated it in Excel in one go. And the way you can calculate that in Excel is you can use confidence.norm. So I could have calculated this part of the value, and if I needed to, depending on how you guys want to actually solve these problems, but let's see, confidence.norm of is alpha, sigma, and n. So alpha for us, what did we say? Well, we said that alpha is 5%. We could see it up here. So we have a 95% interval. So I'm going to put 0.05. The standard deviation, what was that? Population was up here, it's 20. So I'm going to put 20. And the sample size, what was the sample size? The sample size was 50. So let's put the sample size in here, 50. So we can actually put that into Excel and let's see what it comes up with. And let's go to Excel. So what we could have done is we can use equals, confidence.norm, there you go. And so what is alpha? Alpha is 0.05, and then it asks for the standard deviation, which was 20, and then it asks for the sample size, which was 50. And it gives us 5.54. So if that's the margin of error, to get the lower limit, all I have to do is say it's x bar minus the margin of error. So let's do that, see if it gives us the same answer. So x bar minus the margin of error, hopefully it's going to give us 174. Yeah, see, it's given us the same answer as above. We can change it to 2 decimal places, or 3 or 2 or whatever we want it to. And how about this one? So the upper limit is going to be x bar plus the margin of error. So it's going to be x bar plus this margin of error. And there again, it's giving you the same values you could see there. Just take it down to 2 decimal places, 185.54. So that's the second way that you can actually save this. You can actually, solve this to get the result. Okay, so you can use confidence.norm for this part of it.